Okay, now let me begin today's session. So today I believe all of you guys are joining because of your promos that are coming up soon. So I believe most of the schools are having their promotional exams soon, either next week or the following week after next. So today what we'll be going through is basically a very quick revision of your physics. So time passed really quickly. I think the first time I met you guys all was at the start when we were just starting to go through a few concepts of physics, and now I think 1 year have passed, close to 1 year have passed, and you guys have already cleared quite a bit of topic for physics, so you have a bit of understanding of how JC physics works. So for today, because it's a revision session, I'm not going to go through all the main concepts that you guys should know for your exam, but mainly we're going through all the little tips and tricks or things that usually would come up for the exams for your promo at least. So even if let's say you didn't have time to study, at least make sure these are some of the concepts that you know. Okay? So now my quote here say tough times don't last, tough men or women, which are you guys, eat grass and push on. Okay, so it's the last few weeks only. After the promos, you can focus more on your project work or PW. Okay, so I believe you guys have already received the notes on Telegram. So make sure you download them because we'll be using them for this session, as well as there are some practice questions in the back, as well as the solution. Okay, so what we'll be going through today, right? Here's an overview. First of all, I'll give a brief introduction of myself, and then we'll be going through the revision package. So after the revision package, don't hurry to leave first. There'll be a giveaway contest whereby we will be giving out a set of curated notes for, I think, if I'm not wrong, 2 subjects. Okay, so it's actually quite worthwhile to participate in the giveaway contest, and the questions are really easy, don't worry. And then lastly, there will be a Q&A session. So if you guys have any questions that you want to ask me with regards to your revision as well, you can also ask me during this Q&A session. Take it like a mini consultation if you do. Okay, so let's go through firstly. Now, I think some of you guys have already known me. I'm the A-level tutor for OVERMUGGED, and I am an NTU graduate from I'm an NTU graduate of 2 degrees. Number 1 would be my Bachelor in Aerospace Engineering, and the second will be Masters in Education. So, but more importantly is that I've been teaching for 11 years. So if you need help in your studies, you can find me with regards to physics or actually anything in life. Like if you want some lively advice, you can also come and find me. Okay? Now, one thing I want you guys to know is that there's a code here for you guys to, at least spur you on for this last stretch for your promo revision. Is that, life's a stage. You only get one chance to do this well. So why not just make it a good performance? Okay? Revise, prepare, do it, and then just heck it. You're done. Okay? But obviously, you still have the next hurdle, which is your A-level next year. So that will be for next year. We'll leave it to next year. So right now, our first obstacle that we have to cross now is your promo. So just make sure we're going to do a good job for this one. Okay? So without further ado, that was a short introduction. Let's just go through our revision kit. But before I start the revision kit, I just want to mention a few things first. Is that the main reason why we actually hold this promo revision is also to let you guys know about the group tuition classes that we'll be having, because OVERMUGGED would soon have our own center, which is most likely to be held in certain locations around Singapore. So if you guys are interested for a more personalized, group tuition with a small class size, you guys can actually join. So mainly for me, I will have a few classes, H2 physics classes. There's only a few limited slot, mostly about 8 students per class. And just to give you guys a very broad overview of what we'll be doing for the next 12 months leading up to your A-level is that we'll be recapping your J1 topics during the November and December holidays. And based on personal experience, right, what I did was during my December holidays, when I was in J1, I basically recapped the entire thing that I needed to know for J1, as well as to prep a little bit about what I'll be learning in J2, so that you are much more better equipped in the next year. Because based on experience, once you hit J2, right, the moment you start January, it's going to be like choo-choo train all the way to the A levels already. And time will pass really, really fast. Some of you guys may be busy preparing for your university admission, especially for those who will be going overseas. You might have to take extra exams, so there isn't much time left as well. So time is of crucial the moment you step into next year. Okay, so November, December, we'll be recapping our J1 topics. Then January to April, we'll be doing our J2 topics as well as all the topical practices. Then come May, July, we aim to finish the entire syllabus. Even though your school may not have finished the syllabus, we'll aim to do that because we need at least a 5 months buffer to prepare for your A level, which is going to be happening in November. Okay, so August, October is where we'll whack all the prelim papers, all the mock papers, all the 10-year series. Okay, but one interesting thing is that because now we have a center, there is a higher possibility that we can actually conduct practical sessions. So for those of you guys who are worried that you might not do well for your practical exams, especially it's taking 20% of your entire grade, so joining the class will allow you to have access to experimental setup so you can better prepare yourself for your practical exam. Okay, so we will close this sign up the moment all the slots are filled up. So if you want to join, just take note, contact the number here, or you can actually go to OVERMUGGED's website to sign up. Okay, so just to let you guys know where the locations will be held at. The first location we'll be having is at Bukit Timah. The rest, subsequently, we will be opening up at Toa Payoh, Hougang, or Jurong East. Okay, now the time slots here are not fixed yet because once you guys sign up, you will work with me and I will also work according to the schedule to see which time slot suits the best. But these are just the tentative timeline. Okay, so because of that, our next year intake, right, we have some early bird promotion. If let's say you guys sign up early, which you fall under the early bird promotion, you get free curated notes. From what I know, the curated notes are worth about like $120 each for a package. So this is actually quite worth it. And then you will also receive a promo exam kit immediately, which I'll be sending out later if you guys do sign up. Now take note, the deadline is 16 October. There's a reason why I asked you guys to take note of this date. So just remember this date, 16 October. So if let's say you are still unsure, you want to see whether it's useful for you, you can use today's sessions as a gauge, or we will be hosting a trial package in November. So it's a free trial class. You can come with a friend. It's totally free. Just come, take it as a chance to revise your J1 topics or so. You will also receive free curated notes, but you have not that much liberty of choosing time slot because those who join the early bird would have sort of fixed the time slot already. Okay, that will be until 31st October. Then the normal intake would be anytime as if you need help in 2023, you realize that, oh no, shit, I need tuition. So then you just sign up, you will get one free curated note. Usually would be the class that you sign up with, which is physics. Okay, so if you want, just go to the website or you can contact the number, so on and so forth. Okay, so for today, what we'll be going through is basically all the content that I think most of your school would cover for your promo topic. There may be some schools who actually cover a variation of other topics as well, but this would be the bulk of it. Okay, so first topic, kinematics. Now, by now, you guys should be a little bit better at understanding kinematics questions in A level. So the main G's or the main concepts that you need to know is number one, kinematics is made up of two different types of motion, rectilinear motion and projectile motion. Now your rectilinear motion from the term linear, it means that these are straight line motion. Okay, it could be a forward straight line motion or a backward straight line motion or an up or an down motion. But no matter what, these type of motions are considered to be one-dimensional. And in one-dimensional motion, as long as you make sure that your accelerations is a constant value, then you can use any of these three formulas here. V equals to U plus AT, S equals to UT plus half AT squared, or V squared equals to U squared plus 2AS. Okay, make sure your acceleration is constant. But in saying that acceleration is constant, does that mean that it must be equivalent to 9.81? Not necessary. Because if you're talking about upward motion or downward motion, yes, it could be equivalent to 9.81. But when you talk about left or right type of motion, It does not necessarily have to be 9.81, which is the acceleration due to free fall. So it's dependent on the question. So the value of A here is really dependent on the question. But as long as it's a rectilinear motion, you may use this formula. But take note, you must always determine the direction of your motion, meaning to say, first determine your reference point. Is your upward and right positive? If it is, then your downward and your left will be negative. And once you have determined all these, your formula would change a little bit in terms of signing, whereby your positive could be negative, so on and so forth. Okay? But the moment you recognize that your question is a projectile motion, that means your motion is actually released at a projection, whereby there is an angle with respect to the horizontal. That's when straight away you know that it's a two-directional motion. And the moment it's a two-directional motion, you need to always resolve your projectile or resolve your vector. So resolving your vector is resolved into two axes, whereby it is the vertical axis and the horizontal axis. So in these two axes, acceleration is experienced, and that's why it creates a projectile motion. However, the two axes or the two components, right, are independent of each other. Which means what? Which means that when you do questions that involves projectile motion, you will need to analyze the horizontal motion separately from the vertical motion. So if it's a horizontal motion, you can use all of these formula here, but take note, acceleration is now 0, which means that if I have this equation of motion to use, I'm not going to include any of my acceleration. That's why you see V equals to U in the horizontal motion and S equals to UT in the horizontal motion. Okay? However, if it's a vertical motion, then you have uniform vertical acceleration, which usually equals to your gravitational force, gravitational field strength. So in this case here, our acceleration is taken into consideration, and hence my vertical motion equation is changed into this format. You realize the equation is exactly the same. The only thing is that my velocity and my displacement are all changed to the vertical component of my projectile motion. Okay? So one thing to note about projectile motion is this. The acceleration is always acting downwards. Whether or not you are about to launch, your acceleration is acting downwards. Whether you are at the peak, your acceleration is still acting downwards. Whether you are halfway going down, acceleration is also acting downwards. Okay? It's only the direction of motion that changes, which means that at the start, because your acceleration is moving downwards, but your motion, direction of motion is going upwards, that's why you are slowing down. Okay? Then at the peak here, your acceleration is still downwards, but there is no upward motion. So in this case here, we say that you are temporarily not moving, okay, vertically wise, horizontally wise. However, at this portion here, your acceleration is acting downwards. Your direction of motion is also coming downwards. So what happens is that you are accelerating. So when you're going up, you are slightly slowing down until you reach 0. Then the moment you come back down, you're accelerating. Okay? So once you have analyzed the horizontal and the vertical motion separately, in kinematics, sometimes they want you to find, at the end of the day, what is my resultant vector. So once you have your vertical and your horizontal motion, my resultant vector can be calculated using these two components, because usually my horizontal motion is cosine V cosine theta, my vertical motion is V sine theta. Then from there, to find my V, I would use Pythagoras theorem. So this would be the horizontal component square plus the vertical component square, then square root the whole thing to get my resultant. Okay, for those of you guys who are still wondering why is it that horizontal is cosine and vertical is sine, is because if my angle here is theta, opposite here will be O, and then my horizontal is A. So A would usually give cosine. O would usually give sine. Okay, for those who still don't know how to resolve the vectors, but take note, is it always horizontal cosine, vertical sine? Not necessary. It depends on which theta you are looking at. If your theta is here, then it's probably it will give you a different direction. So always based on where your angle is. Understand? So once you have found your resultant vector, make sure you also find your direction. And direction is found by theta. So how do I find theta? Theta will be tangent inverse your vertical component over your horizontal component. So tangent theta is equals to opposite over adjacent. That's how you find it. Understand? Okay. So this is for a very standard projectile motion question, but they might extend to say, okay, now I have a projectile motion. Can I find the maximum height? Can I find the time taken to reach maximum height? Can I find total time? Now, all these different scenarios, right, do not memorize the formula. These are all formulas here that I gave you, but don't memorize them because there is no way you're going to memorize alphabets. And with all the subsequent topics coming out, it's impossible for you to remember. But understand, what does maximum height mean? So when I have a projectile motion that reached the maximum height, you realize something. The only thing that is zero here is that the vertical velocity is zero, means your Vy is zero. So if Vy is zero and I want to find h, one formula that I can use would be Vy squared equals to Uy squared plus 2as. Because I know this is zero, I will definitely have my initial vertical velocity. So then I will want to find my s, which is my displacement. So from there, the moment I sub these to be zero, my initial vertical velocity and the unknown h that I want to find, I can rearrange my formula and get h equals to this. Okay? But the key point I want you to remember is that to find maximum height, vertical velocity is equals to zero. The next one, to find the time taken to reach maximum height. So the time taken to reach maximum height here, what would it be? Same thing, make use of the fact that vertical velocity is equals to zero, because at the highest point, your vertical velocity is indeed equals to zero. Okay, because it's slowing down until it reaches the peak point, momentarily changing direction. But the difference now is that I have vertical velocity, I want to find time. So the only formula I can use would therefore be this, because I have vertical velocity that I want to find, final vertical velocity, I have initial vertical velocity, and I want to find my time. So therefore, using that formula, I can find what's my time taken to go up. You realize something, you realize that my g, there is a negative sign in front. Why? Because by default, I take upwards to be positive. And since at every motion, remember I mentioned acceleration is acting downwards, that's why you will have t up equals to my g here to have a negative sign, and hence t up with this formula. Okay? So then if the question say, now I want the total time taken for the entire journey, that means from here to the top, then back down. What do I have to do? Now, understand that your entire projectile motion is based on the assumption that there is no air resistance. So if there is no air resistance, my projectile motion will be a parabolic, or in layman term, symmetrical. So the time taken to go up will be the time taken to go down. Okay? Otherwise, so that means, right, my first formula can be just total time taken to be 2 times of this, the time taken to go up. So you just take t equals to 2 times the half of the time to go into the middle position. However, if let's say that the question beforehand didn't ask you to find the time to reach maximum point, then what do we have to do? So you ask yourself, in a projectile motion like this, if I start here and I end here, you realize that it is as if my vertical displacement was zero, because displacement being a vector quantity only concerned about my final and my initial position. And since my final and my initial positions are both the same, then I can say, okay, vertical velocity, a vertical displacement is equals to zero. So I want to find vertical displacement. I have vertical displacement. I want to find time. What formula do I use? I will use this one. S equals to ut plus half at squared in the vertical motion direction. And in that case here, you will have S here to be zero, your initial vertical velocity as mentioned, then your acceleration to be negative g because it's acting upwards. Change all your time to be the total time taken for the journey. Then you will get the same formula. Understand? Okay? So it's really understanding what you want and understanding at that point in time, if this is what I want to find, what other information is given to me. Next, given range. For range-wise, it's the horizontal distance covered. So if I have a projectile motion that is like that, symmetrical, my range would be from the starting point to the ending point. So then you ask yourself, how do I find range? Number one, understand that this is a horizontal motion. Horizontal motion, I can only use these two formulas. And since I want to find range, which is the displacement, then I'm only left with the last formula. Okay, so the last formula is horizontal displacement is equals to initial horizontal velocity times time. So therefore, my range is equals to my initial horizontal velocity. Now, what's the time? The time is the time taken for the whole journey. So, which is what you have found earlier on. So just sub it in. This would be your range. Okay? So like I said, don't memorize the formula. It's impossible and they all look the same. So there's no way you can memorize. Understand when I want to find certain thing, what is some conditions that have to be met. Okay, so this is if there was no air resistance. Now what happens if there is air resistance? So this is the column that I have written down all the changes to your certain to the certain things that you want to measure if there is air resistance. So the thing about with air resistance, right, is a lot of things is very ambiguous. So your acceleration changes, your velocity changes, so on and so forth. So as such, there is no way they will ask you to calculate a scenario whereby find me the maximum height if there's air resistance. Okay, they will usually only ask you to explain. So they will say, with air resistance, how would this be different? So with air resistance, how would maximum height be different? So remember, maximum height is the highest vertical height that you will reach. So ask yourself, if I'm moving upwards, where is my air resistance acting? So if I'm going upwards, my air resistance will be acting downwards because it's always acting in the direction opposite of motion. So if my object is here, my object weight is acting downwards as well. That means for maximum height wise, drag force is acting in the same direction as my weight. And as a result, I have an overall greater net force acting downwards. Therefore, this will cause my next acceleration to be much, much greater than my gravity due to free fall. So think of it as your object is being put down by a certain force. It's like trying to stop it from going up. And as a result, the maximum height reached will be lower. Okay? Now what about time taken to reach the top? So same thing, because your drag force is now acting in the same direction as your weight and that your net acceleration is greater than the gravity's, what happens is that it will cause your final vertical speed to be smaller than the initial speed. It's like imagine you're the ball, you're trying to go up to the top and then somebody is pulling you down. So as such, you will start to decelerate. Then your final vertical speed will be smaller. Okay, so as such, the time taken to go up will become shorter as well. Okay, however, when you are talking about time taken to go down, when you're going down, what happens? So imagine now you're a ball going down. Okay, your vertical speed is now going down. Now, where would your drag force be? Your drag force will be going up because it's in the opposite direction as you, direction of motion. However, your weight is also going down. So you realize now that your drag force is acting in the opposite direction as your weight. So this will cause your average speed downwards to be much lesser as compared to your average speed upwards. And since time is distance over speed, end up the time taken for you to go down will be much longer. Okay, so with air resistance, the time to go up is shorter, the time to come down will be longer. Yeah? Okay, then what about range? For my range, how does air resistance affect? So same thing, if this is your object and horizontal motion is moving like that, V. So this is the direction of the motion. However, when you experience air resistance, it will act in the opposite direction as your motion. So drag force is acting in the opposite direction to motion. This means that your horizontal velocity will start to reduce. And because you're traveling slower, the horizontal range will also be reduced. Understand? So for projectile motion, if without air resistance, it's a parabolic symmetrical diagram. With air resistance, you will experience a much smaller maximum height and a much shorter range as well. Understand? Okay, so this is basically the quick revision for kinematics. Now, let's take a look at a question in kinematics here that I have put in to actually expose ourselves more to a kinematics question. So I already attached this in the revision package as well. So the question here says, I have a small mail bag being released from a helicopter, which is ascending steadily at this. The moment it says it's ascending means it's moving upwards. And as such, it is accelerating. This is the speed of ascent, 1.5 meters per second. Now the thing is, because it's moving upwards, downward, we call this type of motion a rectilinear motion, not a projectile motion. So is there a need for you to resolve anything? No. Understand? Which means you can use any of the three formulas. So it says, after 2 seconds, calculate the speed of the mail bag. Since I have my initial velocity, I have the time taken to calculate the sort of like the final speed of the mail bag, I would therefore have to understand this thing first. My helicopter is moving up. But when I release a mail bag, it's going to go down. Can you guys see that? So for the mail bag wise, it is experiencing not only an upward ascent of 1.5 meters per second in terms of speed, it is also experiencing a gravity pulling it down at 9.81. So with all kinematics questions, first state your reference position. And here I take upwards to be positive. So if I want to find the final speed, I have the initial speed and the time. The formula I use will therefore be v equals to u plus at. Okay, so in this case here, my initial speed is 1.5. Since I take upwards to be positive, so it's just 1.5 plus a here would be negative 9.81, and then times the time here. So I'll get the answer negative 18.1 meters per second, which means that your mail package is actually moving downwards at a speed of 18.1 meters per second. Okay, next they want the vertical distance between the parcel below the helicopter. So at 2 seconds later, my parcel would somewhere be here. I want to find the distance that my parcel traveled. So I want distance, I have time, I have acceleration. That's when I use s equals to ut plus half at squared. Okay, but the question here is that I want the vertical distance of the parcel below the helicopter. Now, most of you guys would be able to get the distance traveled by the parcel. Then you will just put that as your answer. However, don't forget, your helicopter is also moving upwards. Okay, the helicopter itself is also moving upwards. So these are like two different bodies separating from each other. So you not only have to calculate the distance traveled by the parcel, you also have to calculate the distance traveled by the helicopter. So for helicopter wise, it's pretty straightforward. The speed is 1.50. It is not accelerating. So just times the time. 2 seconds, it is traveling 3 meters. However, if you're talking about the parcel wise, because it is accelerating, therefore you need to add in the half at squared. Don't forget, your a is negative 9.81. Then you will realize that the parcel is actually traveling at a distance 16.6 meters. And you may be wondering, why is there a negative? It's mainly just because your parcel is traveling downward. So just take the magnitude at 16.6 plus 3. So the total distance traveled by the mail bag would be 19.6. Okay? Then the next one, what are your answers to part B and C if the helicopter is now descending steadily? So now my helicopter is changing direction. My helicopter is now moving downwards instead. So how would my vertical distance be in terms of parcel below the helicopter? So one thing I need to do now is, since they are both traveling downwards, how about let's change our reference position to be downwards as positive. Okay, make our life easier. So first things first, I will need to find the velocity traveling by the parcel, because right now it is experiencing a downward initial speed because of the helicopter. So the final velocity v equals to u plus at, it will be 1.50 now plus 9.81 times 2. So my speed of my parcel is 21.1. So then from there, I can find out what is the total distance traveled by a parcel. Okay, instead of negative 9.81, my speed now is, my acceleration is now positive 9.81. This gives me the total distance of 22.6. Then for my helicopter, because it's traveling downwards at 1.5, same thing times 2. So the distance is 3.0. So the total distance traveled, add them up together, it should give you, shouldn't add them up together, minus 22.6 minus 3 to give you 19.6. Now, why do I actually minus them and not add them up together? Because remember, although your parcel is moving down at a speed of 22.6, your helicopter is also moving down by a displacement of 3. So technically, at 2 seconds later, your helicopter is here. So therefore, the distance would be 22.6 minus 3.0. Okay? Okay? So be very clear of what the question is asking and be very clear of what you are doing. Don't just apply any formula you know and then you'll be like, okay, this is what the formula is, this is what I have, okay, I'm done. Okay, clear? Okay, so that would be for kinematics in terms of rectilinear question wise, because I know projectile motion, most of you guys will have been practicing a lot since it's what that you would be more worried about because it's a new thing in JC, resolving vectors and so on and so forth. Okay, now we will move on to the next part, which is dynamics. So dynamics actually talks about forces and more importantly talks about resultant force. So always keep in mind when you have a dynamic question, the main thing you need to find is a resultant force, because resultant force determines acceleration. Acceleration determines resultant force, vice versa. The direction of the acceleration is also the direction of the resultant force. And once you know that, you can also determine your impulse, your change in momentum, so on and so forth. Okay, so under the topic for dynamics, you will obviously by now should know that you learn Newton's 3 law of motion. And the first law talks about the concept of inertia, whereby an object will be reluctant to start or stop moving. Okay, but what a lot of students tend to neglect is that inertia is dependent on mass. It is not dependent on speed. So it doesn't mean that I'm a small bullet traveling at a larger speed, right? I will have a larger inertia. No, it just means that I have a smaller inertia because I'm a small bullet. Okay, so always use mass to determine inertia. Generally, the larger the mass, the greater the inertia. So that's for Newton's first law, which brings into the concept of equilibrium as well. Because why is there this concept of inertia? Mainly because, right, a lot of the objects tend to like to be in a state of equilibrium. So if any chance they get, right, they were at rest or they are actually in this state where all the forces balances out each other, they will want to go towards that state. So if you have an object suddenly experiencing a change in forces, there is a forward force pushing it, then it disrupts the equilibrium, then this is where it tries to not want to go to that new equilibrium. And that's how inertia come about. Okay? But in dynamics, when we talk about equilibrium, always make sure 2 things. Number 1, resultant force is 0. That means your upward equals to the downward force, your leftward force equals to your rightward force. And you can also make use of the concept that resultant torque is 0, which means your moment is 0. So a lot of times when you do a dynamic question, you might be stuck at it because you are only using resultant force equals to 0. So maybe you can ask yourself this question: is there a way I can also use moment to solve this question? And I do an anti-clockwise moment equals to a clockwise moment to find out any of the forces available. Understand? Okay, so just keep in mind that. Second, Newton's second law of motion. Now, Newton's second law of motion is a little bit interesting because in secondary school, you only learn F net equals to ma. But once you come to JC, you realize that that's not what Newton's really meant. What he said there is that any object's resultant force is actually proportional to the rate of change of momentum. So when somebody asks you to quote Newton's second law of motion, is that his resultant force is directly proportional to the rate of change of momentum, not equals to ma or not equals to dn over dt. Okay, the only 2 scenarios where these come about is when number 1, if mass is constant. So if your question states that your object's mass is not changing, then I can use F net equals to ma. Or in the second case, v equals to dm or over dt. This is whereby they state that the velocity is constant, usually in the case of a rocket. Because for a rocket wise, it is constantly changing or losing mass in terms of burning fossil fuel. Okay, but Newton's second laws wise is always rate of change of momentum directly proportional to your resultant force. Okay, So how do we do a Newton's second law type of question? Always draw the free body diagram of the object that you are interested in before you apply Newton's second law. On top of that, when you look at Newton's second law, you always ask yourself, what kind of forces is this body experiencing? Number one, you can draw things like your weight. You can draw things like an elastic force, especially if there's a spring, an upthrust, especially if there is a fluid like water, normal contact force if there is a surface, and frictional or drag force if they say that the air resistance or frictional force is not negligible. So these are the forces that you can always draw. Okay. Next, Newton's third law simply just said that if a body exerts a force on body B, then body B will exert the equal and opposite force on body A, which means to say that these two types of forces need to be the same nature. If it's an electric force that is being exerted, then the electric force will be exerted back. If it's a gravitational force, then a gravitational force will be exerted back, which means to say your weight is not action-reaction pair of your normal contact force. A lot of people would think that, based on Newton's third law, weight and normal contact force are action-reaction pair. No. Why? Because they are acting on the same body. Always remember, Newton's third law's action-reaction pair acts on different bodies. Okay? So then in dynamics, we extend to learn the concept of impulse as well. What is impulse? Is basically a very simple concept of relating your change in momentum with respect to time. Because, right, impulse is basically that sudden force that you experience within that period of time. So impulse allows us to calculate how much of that force we're actually experiencing within that short period of time, whereby impulse is equivalent to the force times the change in time, assuming that our force is a constant force. If your force is actually a variable force, like for example in a car crash, the force you experience is changing every second, then you can plot a force time graph. The area under the graph would therefore give you the impulse. Okay? So as such, usually when we look at impulse question, right, they want you to find the average force instead, because finding the variable force is there's too much changes. But just keep in mind, to find the average force, I'll just take impulse divided by time. But then in the first place, what is impulse? So this is when Newton also came up with this impulse momentum theorem that states that the impulse of a force acting on an object is actually equals to its change in momentum. So when a body experiences a change in velocity, not only does the kinetic energy change, the momentum changes. And when the momentum changes, that means that the body is experiencing an impulse. And hence, it means that the body is experiencing an average force acting on it for a period of time. Okay, just to recap, impulse is basically mass times velocity. So if I'm looking at change in impulse, I'm taking the final velocity minus the initial velocity. Okay, so if I want to change the extent to which my momentum of a body is changing, then what can I do? I can, number one, alter the magnitude of the force, meaning change the force, or I can change the duration in which the force is acting on, which is actually a very popular concept that they like to test on, because they like to ask like, for example, in a car crash, what's the reason why we need to have airbags? Or how does airbags actually save our life? Because you think about it, when you get involved in a car crash, the total impulse that you experience is the same, whether or not the airbag is there. Okay, so I repeat, the total impulse that you experience, whether or not the airbag is there, is the same during a car crash. However, putting in an airbag will actually prolong the time taken for you to experience the impulse. Since you can't change the force, it's a car crash. How much the car crashed into a wall or something like that, right? It's the same. So you can only play around with the time. So putting an airbag will actually prolong the time taken for you to experience the force. And since the time taken is increased, the impulse is constant. This means that the average force experienced by you, a passenger or a driver, would actually be lower. Okay? Another usage would be like crushable box for storage. Like, you know all your egg boxes, right? Why are they using those kind of like squarish boxes, and each egg nestle very nicely into each hole, and that the box, when you realize the design is a little bit different from just a normal rectangular box, is because they want to prolong the time that an object crushes the box, so that your egg will not experience that much of a force and might not shatter. Okay? So that would be the impulse momentum theorem. Now, the next concept inside dynamics that you are tested on definitely will have one question at least, would be the principle of conservation of linear momentum. That states that the linear momentum of a system will always remain unchanged, whether or not you have different velocity or masses, unless there is an external force acting on it. So if you don't have any external forces, the total momentum will always be conserved, which means to say the initial momentum of your mass A plus the initial momentum of mass B will be equivalent to the final momentum of mass A plus the final momentum of mass B. Okay, so key thing to note is that the total momentum of any scenario will always be conserved. So the types of scenario that you have would be elastic scenario or inelastic or perfectly inelastic. In all these three kinds of collision, right, your momentum is always conserved. And what does that mean? This means use this formula. Understand? Use this formula always. Clear? Okay, if let's say you're stuck, just write down this formula first, then go and see, is there a way I can make use of this formula to find other things? So now, if let's say you understand, okay, so as I was saying, for if it is elastic collision, so what you need to do is you make sure your momentum is conserved and your total kinetic energy is conserved. Now there is a special formula that you can use for elastic collision, which is the relative velocity of approach and separation formula. Because right, if I were to mathematically combine these two equations and sort of like solve simultaneously, you realize that I can cancel away my masses, and what I'm left with is that the relative velocity of approach, meaning the velocity that your two object is coming together, will be equivalent to their relative velocity of separation, the velocity differences if they were to separate each other. Now, because it's a relative velocity, what does that mean? We are comparing their velocity with each other. That means A's velocity with B, B velocities with C. So therefore, relative velocity of approach is UA minus UB equals to BB minus BA. Okay, so it will be the R bar A, B, B, A. Initial velocity. If you cut the final, if for those who can't remember, it's R bar. You know the singer R bar. But anyway, I think you guys will know because they are much older. Anyway, moving on. In elastic collision, always remember only total momentum is conserved. Total kinetic energy is definitely not conserved. Not even might not, definitely is not conserved. So, which gives us a little bit of clue in the sense that usually questions, they will not test you on inelastic because there's really nothing much to fetch. But under inelastic, there is this concept of perfectly inelastic, whereby your objects stick together. So the only thing about objects sticking together, right, in a perfectly inelastic collision is that their final velocity is the same. Okay, so in this case here, they will have the same final velocity and the final momentum can be calculated by adding up their masses together. Okay, so that will be for dynamics, the main G's for dynamics. So let's take a look at a dynamics question here. Now I want to go through this question because I think some students still have a misconception about, not really misconception, but when I face with this question, right, how do I actually do it? Okay, so when we talk about dynamics, remember what I say, find the net force. But before I can find my net force, I will need to draw my free body diagram. So when you are faced with a question like this, there is three types of free body diagram you can draw. Number one, draw a free body diagram of the system as a whole, which means to say you have X plus Y combined. Secondly, you can draw the free body diagram for just X alone. Thirdly, you can also draw the free body diagram for just Y alone. Okay, so there's three free body diagrams you can draw. So the question here say I have two blocks, masses 3 kg and 2 kg. So your first block of mass X is 3 kg, second block of mass Y is 2 kg. Then they also give you a hint. They are accelerated along a force, along the floor by a force of 20 newtons. Which means what are they trying to tell you? They are trying to tell you that the direction of acceleration is in this direction. So understand that if my direction of acceleration is in the forward direction, that means my net force is also in the forward direction. Because remember what I say, the direction of acceleration gives you the direction of net force because of what Newton's second law states. Then they say that given that the frictional force acting on X and Y is 6 and 4, so straight away draw. X, it experiences the frictional force backward since my direction is forward of 6, and for Y, it experiences a frictional force of 4. So now how are we going to draw the free body diagram? Now the question didn't ask you to draw the one for the entire system as a whole, but if I were to draw the entire system as a whole, right, it will look something like that. I will have a massive object here that is made up of 5 kg because it's both your X and your Y combined together. There is a forward force of 20 Newton, and this entire object is experiencing a backward force of, due to your friction, 10 Newton. Can you see that? So where is my net force pointing? My net force is pointing in the forward direction like this, which makes sense because 20 minus 10. Okay, so this is the system's free body diagram. But now if I want to draw the free body diagram for X, what would it be? So take it that Y didn't exist, just look at X. What are the forces acting on X? Number 1, X here, obviously you have the weight and the normal contact force. Number 2, X experiences a force 20 Newton acting on it. Number 3, there is a frictional force of X, which is a 6 Newton. And then number 4, we realize that X experiences a action-reaction force that Y exerts on it not because of the friction, but Y pushes against X. So this is the force that Y acts on X. Okay. Then now if I draw on Y, take it that X doesn't exist, only Y. Then you realize actually Y doesn't have a forward 20 Newton. Can you see that? The 20 Newton actually acts only on X of the entire system. So for Y, it will just experience its own frictional force, the one that is 4 Newton. Then the action-reaction force that X will exert on Y. Take note, this force and this force have to be the same because they are action-reaction pair. Then obviously the weight and the normal contact force. These are the individual free body diagrams. Understand? So that means, right, if I were to look at X alone, I know that the net force is forward. That means what is the net force made up of? I'm not going to concern myself with my upward and downward force because by right they should be the same. Okay, so that means my net force for X is 20 Newton, which is this direction, minus the one acting backwards, minus my Fyx, minus my Fx. This one is just 6 Newton. Can you see that? Whereas for Y, the net force is acting forward. So therefore, the resultant force would be my Fxy, which is this force, minus my Fy, which is my 4 Newtons. Okay? So that's how we use the free body diagram and link it to Newton's second law. Because the moment once we have that, I can sub it equals to ma. Okay? So then they say here, based on Newton's second law of motion, write 3 equations that govern the motions of the object. So for x, y, this is what I have. For the forces acting on y, this is what I have. But the question is, how am I going to find my acceleration? So remember I asked you guys to draw the system. You realize something. You realize that your F net is made up of what? 20 minus 10, which gives you 10 Newton. Correct? Then in that case here, my F net is equals to ma. So if my resultant force is 10, my total combined mass is 5. That means my acceleration will be equals to 2. Understand? Okay. So therefore, from there, you can just substitute in the acceleration, and as a result, you can get out your entire acceleration of the object. Okay? Here. Okay, so then it says, what are the magnitude of the forces that block Y exert on block X? That means they are looking for this one now. So now, if I can use any of the equation here, and I sub in A to be 2, let's say I want to use this formula here. I know that 14 minus Fyx is equals to 3A, and I know that A is 2 based on my calculation from the free body diagram of the system. Then this will be equals to 6. That means Fyx will therefore be equals to 14 minus 6, which is 8 Newton. Okay, then from there, the force that X exerts on Y is 8, and the force that Y exerts on X will also be 8 because of Newton's third law. Okay, so for a dynamics question, always pretty straightforward. Draw your free body diagram and then ask yourself, what kind of free body diagram can I draw? Okay, the system always determines the acceleration. The individual components or the individual objects will always use or follow the same acceleration. Okay, so that was for dynamics. Now, the next one we'll be looking at is forces. So for forces, this goes more in depth into the different types of forces that could, at the end of the day, lead to your resultant force, which is your net force, which is then what you use in dynamics. Now, in forces, there are many different types of forces that you need to know. Number one is Hooke's law. Hooke's law basically explains to you about the elastic force, basically tension. So any magnitude of tension in an elastic body will always be directly proportional to the extension, whereby you have the formula F equals to Kx. Now take note, this formula here in this case is talking about how your extension is up to the amount of tension experienced by a body. So always remember to calculate your extension. However, in question, they like to test Hooke's law in a mass spring system concept. So a mass spring system concept you need to be very, very familiar with. Now, what does a mass spring system means, right? It means I have a spring attached to a mass. Okay, so if I have a spring detached from a mass at first, right, you realize that they just have a mass itself and a spring itself, two separate bodies. However, the moment you put them together, you realize something. Your object experiences a weight force, mg. But because it is being put on a string, it also experiences a tension, kx. Okay, so if let's say your object is now being stretched by a certain distance, then the mass, the weight stays the same at mg, but now the tension will be larger because now I'm pulling it and extending it. Okay, so at equilibrium position, because the net force is 0, because they already say it's at equilibrium, my weight is equals to my tension. However, if there is any additional displacement, what happens? I will have a net force. Why? My net force is upwards. Can you see that? Because now my tension is greater than my weight. Okay, so as a result, what happens is that if we were to release, this gives the ball a restoring force to go back up. Then you displace it downwards. Okay? Okay, so now the next one, pressure. So just understand for pressure, this concept, you use different formulas for different type of substances. If a substance is actually a solid, then you use force per unit area. But if a substance is a fluid, which is a liquid or a gas, then you use rho GH. Okay, so take note of what substances you are looking at, then you use the right pressure formula. Now, the harder concept to grasp is actually upthrust. Because a lot of people, I realize, tend not to understand upthrust. Always remember that upthrust is a force and it's present as long as you have a liquid, or as long as you have an object submerged or on a liquid. Because the moment it is on a liquid, the liquid acts like a surface. So if you think about it, if an object is on a normal surface, there is a normal contact force. However, if it's on a liquid, the liquid is like a form of surface, but it doesn't experience a normal contact force. Instead, it experiences what we call an upthrust. Okay, so the upthrust is actually a net upward force that is exerted by the fluid, in our case, liquid, on a body that is submerged in it. So upthrust is given by the formula density of the fluid times the volume that is being displaced times gravity. Now, why did we come up with this formula? It's mainly because of Archimedes. He actually mentioned that if let's say I have a body submerged inside a liquid, and if it's submerged and it's not moving, that means it's at an equilibrium state. So we can say that the upthrust of a body is equivalent to the weight of the body. Okay, or it is also equivalent to the weight of the fluid that is being displaced. Yeah. So weight is mass times gravitational field strength, and my mass is fluid times density times volume. So that's how you come out with the equation. Okay. So take note, upthrust is always in the upward direction because it's exerted by the fluid on the body. Okay. Next concept of upthrust is the concept of principle of flotation. So let's say the question says, oh, my object is floating on the surface, half submerged but it's floating. then in that case, do we say that the arc thrust is equivalent to the mass of the weight of the body? No, because only this portion here is submerged inside the liquid. So the principle of flotation concept then mean that the weight of the floating body will therefore be equal to the arc thrust. Okay? Okay, then in forces, you also come across this concept of equilibrium, which is a very important concept because you need to make sure that in order you can use the equations or all the formulas, your object has to be in equilibrium and it's not moving, because moving means that there's a lot of other things that is being changed. So when your body is in equilibrium, what can we say? The net external forces is zero. And what does that mean physically? It means that in physics terms, all the horizontal forces is zero, all the vertical forces add up to be zero. Upward force equals downward force. And the net torque is also zero. All clockwise moment equals to any anti-clockwise moment, which is observed by the principle of conservation of momentum. Okay? Now, however, for bodies that have more than one forces, if it's two forces, it's very straightforward. Either up minus down or down minus up, left minus right, so on and so forth. But if it's a three-force system, how do I form an equilibrium? Always remember, a three-force system forms a closed vector triangle. So if let's say I have one force here, and they say that draw the third force that results in an equilibrium system, then extend your forces until they intersect at a certain point. This intersection point is where your third force will be directing towards. Okay? So that's how you draw the resultant forces for most forces question. Okay, clear? So let's take a look at a force question here, a force question that we want to look at, which is a common question, something like you have a crane or a lever attached to a wall, and how do I find the forces acting on it? So for example, here I have a crane, mass 3,000 kg, supporting a load of 10,000 kg as shown. So the weight of the crane is measured, present. The weight of the load is also present here. Okay, and always remember, weight is acting downward, so we have weight of load. Now the crane is pivoted. They even told you where the pivot is, and that's the keyword to use turning effect of forces. There is a frictionless pin at A, meaning there shouldn't be any forces here, and it's rest against a smooth support. There is a smooth support here at B. Okay, so which means to say that if this is a support, there could be a force acting in this direction. You see that? And how does that even work? So you realize that because my crane is in this direction and my load is in this direction, if they were to test you on forces, what they could most likely test you on, right, would want you to resolve your forces into its specific direction. Okay, but as of now, they didn't say anything, so we just carry on first. Now it says, determine the magnitude of the reaction force at A and at B. So you see there are reaction forces at both A and B. So first things first, let's take the magnitude of the reaction force pivoted at A. So we take moments about A. Then you realize something is that if my pivot is here and this is my weight, the weight here itself creates what we call a clockwise moment, and the weight of the load also creates a clockwise moment. Can you see that? However, the force here that is acting in the direction at B here, the contact force, is in the anti-clockwise moment. So using turning effect of forces, taking moment about A, clockwise moment equals to anti-clockwise moment, whereby the weight times 2, the weight of the crane times 2, plus the weight of the load times 6 is equivalent to the normal contact force at B times the perpendicular distance, which is 1. So this will give me the normal contact force at B to be 6.47. Okay, then you realize something. How am I going to find the reaction forces at pin A? Now, at pin A here, you realize that because the entire system is in equilibrium, I can say that my horizontal forces add up to become 0, and my vertical forces add up to become 0 as well. So your horizontal forces is moving in this direction here. There's only one horizontal force, which is the one for P. Then there is also a downward force, which means that at A, there is two forces. At A, there is a horizontal force here, and there is also an upward force here. Can you see that? A horizontal and an upward force that is acting on A, because it needs to counterbalance these two forces. So add up the weight of your A, you will get this. So since at point A there are two forces acting on it, what does that mean? There would therefore be a reaction force at A. And this reaction force is in this direction here. Understand? And this is the force at A. So that's how you determine where the direction of the reaction force is. Always find out what are the forces acting on it. Okay? So then from there, our reaction force at A by using Pythagoras theorem, this is the value. Yeah? Okay, so let's move on to the next one, work energy power. Work energy power, this topic, right, is pretty straightforward because it's only testing you on what is work done, what are the different energies that you have, and power. So the only concept that you need to take note of is, firstly, work done is the product of force and displacement in the direction of the force. So what they can test you on or what they can twist about, right, is basically the direction. So they might resolve your direction in a certain vectorial direction. So what you need to do is make it into the horizontal and the vertical components. Okay. But one thing about work done is, especially when you're doing the topic of the thermal, is that you will have this concept of work done by and work done on. But for now, just remember, the work done by a certain substance is equivalent to the negative work done on that substance. So it's just the opposite of it. Understand? Okay. Next, you also learn the concept of principle of conservation of energy, whereby in work energy power, every energy lost by a system is equivalent to work done by the system. So there is this concept about work done and energy being separate concepts. Although they are two different terms, they mean the same thing, which means that my work done is equivalent to my energy. So in a system, energy is being conserved, which means that if your system doesn't experience any external force acting on it, the total initial energy should be equal to the total final energy. However, if resistive forces are present, there would be a loss in your kinetic and potential energy. We call that the loss in mechanical energy. And all these losses is mainly used to go against resistive forces. Okay? So because of that, why do we actually do work? If let's say my energy is changing and total is not changing, then what is going on? And the concept is because any energy loss or energy that is newly created is due to the presence of work. If let's say you are losing energy, it probably means that you are doing work on certain things. If you are losing kinetic energy, you are doing work to raise your height, and hence an increase in gravitational potential energy. If you are decreasing gravitational potential energy because you're losing height, that means you're doing work to increase your speed. So your KE increases. So always remember, the net work done on an object will be equivalent to the change in the energy of the object. So I can say that I have kinetic energy changing, half n v square minus u square to be equivalent to my work done. Or potential energy changing, mg, the change in height, to be equivalent to my work done. Okay, so that is the concept for work energy power. Now, let's move on to the next one, which is the concept on motions in a circle, which is circular motion. So for circular motion wise, right, the main thing you need to remember is that for any object or any body that is moving in a circle, okay, there is a force experienced by the object, and that is the centripetal force. Now your centripetal force, right, always remember it is a resultant force. It is a force that is derived because of the existing forces of the body. Which means to say, if I were to draw a free body diagram, I do not include a resultant force on the free body diagram. Okay? And because my centripetal force always acts towards the center, it usually it doesn't do any work. Why? Because my velocity will always be tangential to the direction of my resultant force or my centripetal force. As such, my centripetal force does no work. Okay? So centripetal force can be calculated by a formula mr omega square or mv square over r. And because there is a centripetal force that is a resultant force and F net equals to ma, therefore, we have this understanding that there is also a centripetal acceleration. So the centripetal acceleration is basically the acceleration that is acting perpendicular to your velocity. It represents your change in velocity direction. because the direction is moving like that, then like that. So the change is always directed towards the center. And the formula will be acceleration equals to v squared over r, or equals to r omega squared. Okay? Then how do I find omega? Omega is the same for in this topic as well as in waves. It is 2 pi over the period of rotation, or 2 pi f. Okay? So here are some of the different circular motion questions that could come out, and how do I find out the direction of the resultant force? So first things first, if let's say I have a question whereby they say, oh, my airplane is actually being bent at a certain angle, the first thing I need to do is resolve my forces. You realize that centripetal force always points towards the center, which means now I will have to resolve my lift. So resolving my lift here, I will therefore get this direction here to be L sine theta, and this one to be L cosine theta, which means to say my centripetal force is equivalent to L sine theta. And my weight, which is my mg, is directly equivalent to my L cosine theta. You see that? Based on just force resolving. Okay, then from there, I can just straight away equate these two and these over. Yeah. Now, what happens if, let's say, I have a pendulum or a bob swinging in a circle like this? So for this pendulum bob swinging in a circle, first, identify what are the forces acting on it. Number one, there is the weight force acting on it here. So W equals to mg. Next, I will have a tension force acting in this direction. So this is my tension force. So recognize that these are all the forces that are present, then resolve your force. So you realize I can resolve my tension force in this direction and in this direction. Okay, so for those who are not that good in trigo, just see, this is a right angle triangle. If this is theta, this will be 90 minus theta. And since this is 90, that means this angle here at the end of the day is the same as theta. Otherwise, you can do the Z, alternate angle. Okay, so then from there, so this is your theta, any angle, any line here would be the opposite, which means this will be T sine theta, and this is T cosine theta. You see that? So from there, I can say my centripetal force is T sine theta, and is equals to mr omega squared. Whereas my weight is equivalent to T cosine theta. Okay? Okay, next, what happens if I have a car that is actually at a bank, and moving at a bank? Now, a lot of students tend to make the mistake in this case here. They resolve the weight instead of the normal contact force. Wrong, because remember, normal contact force towards the center. So instead of resolving your weight, resolve your normal contact force. Yeah? So same thing. This is my triangle. If this is theta, this is 90 minus theta. Now, if this is 90 minus theta, then in this case here, this angle here would be your theta. So same thing, opposite, n sine theta, n cosine theta, like that. Okay, so as such, you can then now see, it's pretty obvious that your centripetal force is n sine theta, your normal contact force, which is mr omega squared, or mv squared over r, depending on what they want you to find. Then my weight, which is my mg, is n cosine theta. Understand? Okay. Okay, so that is if it's a car at the bank. The next one, what happens if I have a bucket, okay, that is moving in circles? Now, for this type of bucket question, right, you always have to ask yourself, what is the forces acting on the bucket? So at the top, my bucket will have its own weight. On top of that, the water inside the bucket experience a normal contact force, which means to say, at the top part here, my normal contact force is my weight plus my my centripetal force is my weight plus my normal contact force. Okay. However, if let's say my bucket is now at the bottom, at the bottom, my weight is acting downwards, but my normal contact force is acting upwards because it's pushing against the water. So the centripetal force at the bottom will be much smaller. It will be my normal contact force minus the weight. Because always remember, centripetal force is acting inwards. Okay? Okay? So usually they will say, oh, then find me the velocity at the top. or find me the velocity at the bottom. So this is how we actually find. Just substituting it to be mv squared over r. Okay, another scenario is if let's say I have a pendulum bob, and pendulum bob is instead of swinging horizontally, it is swinging vertically like that, up, down, up, down. So for this one here, it's the same thing as what we always do. First, find out what are the forces acting on the bob. Number one, tension. Tension is always acting away from the object. So just draw the direction away from the object, there's a tension. Then at the top here, it experiences its own weight. Okay, so at the top, what's my centripetal force? My centripetal force would be tension plus the weight of the object. Okay, so the tension at the top here would be centripetal force minus weight. At the bottom, however, let's say this is my bottom, then my bob is like that. My tension is going upward, but my weight is going downward. So the centripetal force is equal to tension minus weight, which means my tension is centripetal force plus. So you can see something. The tension at the bottom will always be larger than the tension at the top. So it's tugging onto the string much harder at the bottom than at the top. Okay? So these are all the different scenarios should you come across with a circular motion question. Yeah? Okay, so always take note of what force you need to resolve. It's not always, resolve my weight or resolve my this. I need to make something horizontal. No, always be clear. Centripetal force always pointing towards the center, horizontally. Okay, not slanting. Okay, so we take a look at this question here. Now, this is a bicycle cyclist making a left turn on a rough road. Okay, so what are the forces acting on it? Number one, he's making a left turn on a rough road. Rough means there is the presence of friction. Okay, then at a constant speed. So he's most likely changing his direction. Hence, he experiences a centripetal force. Total mass of the bicycle and the rider is m, and the combined center of gravity is at g. Now, if R is the resultant force of the normal contact force and the frictional force acting on the bicycle, so they recognize that there is a frictional force acting on the bicycle. What vector diagram represents the direction of forces acting on the bicycle and the rider? So, number one, center of gravity is at G. So this is where the weight will act on. And as such, I put my cross there. This is my weight, mg. Okay. Now, since it's making a left turn, means it's turning towards this direction, that means before that, the normal contact force would be upward here, correct? And since it's making a left turn in this direction, that means the frictional force would be towards the left or right. So if your bicycle cyclist is actually making a direction towards the left, what happens is that your frictional force will be in this direction here. Okay, so as such, your normal contact force and your frictional force will cause it to experience a reaction force in this direction. Okay, how do I know it's pointing in this direction? Because remember, all your forces will meet at an intersection. So by right, your weight and your reaction force should also meet at an intersection. If your reaction force is going this way, there is no way it's going to meet your weight as well. Okay, then on top of that, is there other forces? Now you'll be saying, then what about a centripetal force? Because now most likely it's turning inside out. It's making a left turn. It's moving in a circle. But always remember, centripetal force is a resultant force. You do not draw it in a free body diagram, understand? But recognize that it is the resultant force between the R and the weight that gives rise to a centripetal force in this direction. Okay? So any equation that has, or any diagram that has centripetal force present in it will not be correct. Your only correct answer will be C. Clear? Okay, so that's how we determine the direction. Now, the next one, here. I have a particle suspended from a point by an inextendable string. So I have a string, that means there will be a tension force. Projected with a velocity at B, with V, perpendicular to AB, which is just sufficient for it to reach C. Now show that if the string were just to be taut when the particle reaches C, that the speed at the top there will be V equals to square root GL. Now, in order to understand this concept, this question, we need to understand what is the meaning of taut. And taut means what? Taut means it's tight, okay, but not breakable yet. It didn't break yet. So at the top here, since it's moving in a circular motion, I first recognize that there is a weight, and because at the top, right, there's a string connected to it, there will also be a downward tension force. Which means to say, the total centripetal force at the top is provided by the tension and the weight, and hence, centripetal force mv squared over r, which is my L, is equals to tension plus weight. But at the top there, because I want it to be taut, I need my tension to be positive. So if tension is positive, how do I find tension from here? Tension is my centripetal force minus my weight. And since it needs to be greater than 0, I'll therefore equate that equation to be greater than 0. So doing a little bit of shifting around, cancelling my mass, and then bringing my length over, I will get the speed at the top to be greater than square root GL. Okay? Next, find the speed in terms of G and L that the particle should be projected with at B. So they want you to find what speed it should come out from here so that it can reach here. So the only concept we can use is conservation of energy, which states that the kinetic energy needed by the object to be projected from here needs to be sufficient enough to reach the top, which means it needs to be equivalent to the GPE of the ball. So simply just substitute in total kinetic energy at A to be total energy at B. A lot of students tend to make the misconception that at B, right, there's only GPE. Why? Because they forget that there is a velocity. So that means at the top, you will also need to add in the kinetic energy at the top. Understand? Okay, so therefore, half mv squared at the bottom equals to half mv squared at the top plus the height, the change in GPE and GH. Then from there, just substitute in the v that you have found earlier on, and hence shift around to get the velocity at the bottom that it needs to be released at. Okay, so understand that this concept is talking about the conservation of energy. Energy at the bottom must be total energy at the top. Yeah? Okay, now, another question that you come across is this washing machine question. Because why? Washing machine is moving in a circle. So for a washing machine question, you have a cylindrical tub here containing wet clothes rotating stably. So the clothes will dry uniformly, they are made to tumble. The rate of rotation of the smooth wall tub is chosen so that a piece of cloth will lose contact with the tub when the cloth is at an angle. Lose contact means totally no normal reaction force when the angle is at 68 degrees above the horizontal. Now, if the radius of the tub is given to be 0.330 meter, what angular velocity is needed? So they want you to find your omega, and omega can be found by centripetal force. So understand that, okay, if let's say I'm my object, I am a load here at the top, what are the forces that are present? Number one, obviously, I have my own weight, the weight of the clothes. And then they also say loose contact, which gives you the hint that there is a normal contact force present. So normal contact force in this direction. Okay, you realize something. The normal contact force is at an angle of 68 degrees. So you draw horizontal reference, 68. So the resultant force gives you the centripetal force. The resultant of these two gives you the centripetal force. And how do I find the resultant? Now, resolve my normal contact force. So my normal contact force in this case here would be n sine 68 and then n cosine 68. So you realize centripetal force is all pointing towards the center. So in that case, my centripetal force is made up of my weight plus the vertical component of my normal contact force. Can you see that? So then they say in order to lose contact, that means my normal contact force has to be 0. So once this is 0, that means my centripetal force is straight away just equivalent to my weight. Okay, so in that case here, I can find my omega straight away. Yeah? Okay, so this is how we actually answer it in the case of a washing machine question. Now, the next one, gravitational field. So for gravitational field, this topic, take note. When we learn gravitational field, right, there is 4 main things that you need to learned about, number one, your force, your vector quantities, your force and your gravitational field strength, then your scalar quantities, your gravitational potential energy, and your gravitational potential. So the formulas are all as such. We realize that the vectors are just differ each other by the mass of the object because gravitational field strength is per unit mass. But my scalars differ each other not only by my mass, they differ from your vector quantity by a distance, which is your r. Okay, so for scalar wise, because the direction in this case here for scalar quantity is not defined, we have to put our negative sign here because in terms of energy wise, gravitational field is always an attractive field. But when we talk about potential energies of potential, we are actually taking it to be the work done by an external force in the opposite direction. So that's why there's a negative to it. So if I were to relate my potential to my vectors, that means my scalars to my vectors, you'll realize that your potential energy and your force is related to each other. Your potential and your gravitational field strength is related to each other. Whereby, to find the force of a gravitational force acting on an object, I will take the negative gradient of a potential energy displacement graph. And if I want to find my gravitational field strength, I will take the negative gradient of my potential displacement graph. Okay, so that is what you learn in gravitational field. The most important thing, however, is the different application questions in the case of satellite motion or orbiting bodies. So if let's say I have an orbiting body or a satellite moving around my planet, I have to understand that it is moving in a circular motion. So there must be a force that provides this centripetal force. And the only force experienced by my object moving in circle would be my gravitational force. So if the moment they say there is a satellite motion or an orbiting body, understand that the gravitational force is equal to the centripetal force. Then from there, I can say gmm over r squared equals to mr omega squared. Then if I want to find things like period, I can find it from my omega. If I want to find things like radius, I can find it from my r here. If I want to find things like the mass of a body, I can also find it from here. Understand? Okay. But this equation helps us to understand the concept that the square of the period is directly proportional to the mass, inversely proportional to the mass, and directly proportional to the radius. Now, I realize a lot of you just tend to just read this through and don't really understand. You have to take note that when you talk about the period of a satellite body, if you were to increase the radius, then it will take a longer time to complete its orbit. If you were to increase the mass of the satellite body, this will cause the period taken to decrease accordingly. Understand? Next, escape velocity. Escape velocity is actually the minimum velocity that a body must have in order for it to escape from the influence of Earth's gravitational field. So they already gave you the hint. Escapes Earth's gravitational field. And since I'm talking about speed, means I have to involve a certain form of kinetic energy. And therefore, to find my escape velocity, my kinetic energy needs to be greater than my GPE, gravitational potential energy. But if I want to find minimum, I just have to equate them together. Then once I equate half mv squared to be equals to GPE, just the magnitude alone, I can find my velocity from there. Understand? So it will be square root 2 gm over r. So that's what we do when we want to find escape velocity. Next, total energies of a body. So for an orbiting body, to find the total energy, we add the potential energy with the kinetic energy. Now, potential energy we already know is gravitational potential energy. So this will be negative gmm over r. Then if it were to be kinetic energy, I can sub in the equation for velocity. Kinetic energy is equivalent to half mv squared. So in this case here, it's half times m times square these, I will just get 2 gm over r. Then from there, I will have cancel gmm over 2r. Okay, so this would be your kinetic energy. Add together, you will get your total energy to be equivalent to negative gmm over r over 2r. Then when we draw the formula, when we draw the graph here, it will look something like that. Only your total energy and your potential energy is negative. That's why they are below the x-axis. But your kinetic energy is positive, so it's above the x-axis. Clear? Okay. Next, in gravitational field, the concept of geostationary orbits is also important. For those that don't understand what geostationary orbit is, understand that this is actually an object that remains in a fixed position relative to any point on Earth. Meaning to say that if you are on Earth and you look up, you will always see that object in orbit. But the main important thing you need to know is the period of orbit is always 1 day, 24 hours. Which means if you want to find the angular velocity, make sure you change your t to be equals to 24 times 60 times 60. Okay, understand that for geostationary orbit, orbital period is 24 hours, and the direction of rotation for geostationary orbit is the same as the Earth. That means it will start from east and ends at west. Okay, and it also lies above the equator for geostationary orbit. Now, the last concept for gravitational field is this thing called binary stars. I realize binary stars keeps coming out in a lot of the questions. What is a binary star system? A binary star system is a system where you have two masses, two bodies that are actually orbiting with respect or around their center of mass. So they are orbiting together. So if this moves here, this moves here. Okay? So these two stars are actually orbiting about their common center of mass. So another way for them to test you on binary star, other than not saying that binary star, is they will say, oh, the two stars are orbiting about their common center of mass. So always remember, for this type of system, omega is the same. So I can say that the gravitational force provides the centripetal force. Then from there, I can calculate what my omega is. Okay, so this is for a binary star system. So if we take a look at gravitational field here now, like this question, it says, two stars, equal masses m, move with a constant speed v in a circular orbit, radius r, about their common center of mass. So this saying that this is a binary star system. So in this case here, they say, write down expression for G, M, in terms of G, M, and R, the net force on each star. So you realize that the net force means what? Their centripetal force. The centripetal force is always acting towards the center. That's what causes them to move in a circle. Understand? So how do we find the centripetal force or the net force acting on each star? You realize that the net force acting on this star is equivalent to the gravitational force. You see that? So the gravitational force is equals to what? Fc equals to Fg. Fg is equals to Gmm. Now 2 m's because they are of equal mass over the r is the distance between them, and the distance between them is 2r. So this will be 2r, the whole thing squared. So if we were to simplify that, we get 2gm over 4r squared. Okay, so this is the centripetal force acting on each star, which is this one here. Next, the orbital period for each star. So how do I find the orbital period? Same thing. I know that the centripetal force is equal to the gravitational force. So centripetal force is mr omega squared. Correct? So how about I write this down first? Mr omega squared equals to gm squared over 4r. Now, I want you guys to pay attention to something. When I talk about gravitational force, the r here is the distance between the two planets. That's why it is 2r. But when I talk about my centripetal force with respect to one body, the r here is the radius of orbit, which is just only 1r. So why I want to mention this is because sometimes you might just do this, Fg, then you will say mr omega square equals to gmm over r squared. Then you will just bring this up and say mr cubed omega square equals to gmm. This is not correct because the r that they are talking about is different types of r. Understand? Only when you put this r into the other, in terms of the same r that you're talking about in gravitational force, then you can put them together. So in this case here, this is just only one r. Yeah? Then from there, I can cancel 1m. I will get r omega square equals to gm over 4r squared. Then omega square equals to gm over 4r cubed. because now these two are the same arc. Then I want to find period. I just make sure I know that omega is equals to 2 pi over t. Then from there, I just have to do a bit of shifting to find my period t. And that will give me this value here. Understand? So this is important for a binary star system. Try not to mess up your radiuses. Yeah? Okay, the next one, let's take a look at this part here, the weightlessness in orbit. So there are some questions which also test you on the concept of weightlessness, whereby I have an astronaut inside a space shuttle, and then it's in space. Does this astronaut experiences weightless if, let's say, it's orbiting around the Earth? Yes, he does. Because why? Number one, let's say we consider the astronaut is actually standing on a weighing balance. What are the forces that is acting on this entire system on its own? Now, in this entire system, there is only a gravitational force. There is no air resistance. There is nothing because in space, there is no air. So the gravitational force therefore provides the net force and hence the centripetal force. So for the system-wise, gravitational force is equal to centripetal force, and gravitational force is equal to the mass of the system times the gravitational field strength at that point, not necessarily 9.81. However, that is equivalent to the centripetal force. As such, it will be mass of the system times the centripetal acceleration. So we can say that the centripetal acceleration experienced by the system is equivalent to g, which is your acceleration due to free fall. As such, my space shuttle and the space astronaut inside is experiencing weightlessness. Because what's the concept of weightlessness? The concept of weightlessness is free falling. Okay, and free falling means falling with the acceleration of g. Okay. However, if we were to look on the inside, just the astronaut alone, now at a certain point in time of the orbit, you realize that the astronaut has two forces acting on it. Number one, the weight due to the Earth. Number two, the normal contact force, because the astronaut is standing on a platform. If the astronaut is floating inside, then there is no normal contact force, it's fine. But if the astronaut is standing on a platform, then yes, it is experiencing a normal contact force. So these two forces will cause it to experience a net force, ma. But my weight will be greater because it's orbiting in a circle, so the centripetal force is always pointing towards the Earth. Understand? So if, let's say, my astronaut experiences the same acceleration at g, that means I'm going to put this a as g, then you realize something. I can cancel my mg and mg here, which means to say that the normal contact force experienced by the astronaut is equal to 0, only if the acceleration is equal to the one that is due to free fall. Then yes, your astronaut experienced due to free fall. Understand? However, in the one question that they like to ask is also, what happens now if my space shuttle enters Earth atmosphere? Now, when your space shuttles enter Earth atmosphere, your acceleration will then start to decrease. Why? Because of the presence of drag force. So you have F drag acting. So you have F drag acting upwards, then your net force will decrease. Net force will decrease, and as such, your acceleration will be smaller than g. So what happens is that your system will start to move at a slower speed. It will start to accelerate lesser down towards the Earth's atmosphere. And when your system starts to accelerate lesser, your astronaut will now experience a force up. The acceleration that the astronaut experiences here will be much lower. You see that? So when it's experiencing a much lower acceleration, if I were to find the value of n, now your n value becomes higher. So when your n value becomes higher, because n is equal to mg minus ma. So if a here is no longer g, but a is less than g, that means my n here would be much larger. And as such, your astronaut is experiencing a non-zero normal contact force. So this means the astronaut is no longer weightlessness. And the non-zero contact force means the astronaut is crashing against the surface of the space shuttle. Okay, clear? Okay, so that would be for gravitational force, field force, as well as G. Now we look into the next part, which is the potential graphs, as well as the field strength graph, because I think a lot of the questions also test you on your graph drawing skills. Okay, so You need to be able to know how to draw the graph for G versus R, which is a gravitational field strength versus R first. Let's say this is Earth, this is Moon, and I'm an object in the middle. Okay, understand that because I'm an object and a mass, Earth itself as a mass, there will always be a force attracting me towards Earth, and Moon itself is also a mass greater than the object. There will be a force, there will be a gravitational field pointing towards the Moon. So how does it change? Now, if my object is here, obviously my gravitational field strength will be the highest, which is in this case here, the highest. Now, then you'll be like, but it's in a negative direction, negative value. How is it the greatest? So always understand that in science, in physics, negative just means opposite direction, that's all. Because right now we are taking the positive direction to be towards the right. Understand? So therefore, for Earth, the magnitude is still the largest. So pay attention to this pink one first. This is the gravitational field strength experienced by the object if it's just Earth alone. As I move across, it will get smaller and smaller and smaller. Can you see that? Okay. Whereas with respect to the Moon, this is the one above. And when I'm here nearer to the Moon's surface, it will be the maximum. But obviously still lower than the one as compared to Earth, because Moon is smaller in mass compared to Earth. Then as I move further away from the Moon, it starts to get closer towards 0. So if I were to add these two graphs together, what happens is that it will increase because Moon 1 is still close to 0. So it will follow the one for Earth. And then at this point in time where they both, for the gravitational field strength for Moon to be the lowest and gravitational field strength for Earth to be the highest, they will cancel out each other to 0. Then after that, when the Earth once is much closer to 0, the Moon, it will follow the shape of the Moon. Okay? So this is how you draw the gravitational field strength with respect to distance. Now, if part B, I want to sketch gravitational potential with respect to radius. Oh wait, for that. So if I want to draw the one for force, will it be the same graph? Yes, because force just multiply the mass of your object value. So it will be the same shape as well. Next, if I were to draw gravitational potential, so this is how it looks like. So you'll be wondering, why is the gravitational potential at the bottom? Okay, because you see, gravitational potential is the work done in bringing that object from infinity to a certain point on Earth. So if my mass of the object is here, then my gravitational potential is actually the maximum. So can you see, potential of Earth is actually the maximum. And as I move away, I'm moving closer towards 0 because with reference to Earth, infinity is 0 potential. So therefore, I'm decreasing until I reach 0. Then same for Moon. Potential is negative but smaller because the mass of Moon is smaller. Then it will increase until decrease until it becomes 0. So then now, if I were to add these two graphs to draw the resultant, initially I'll follow the shape of Earth because Moon 1 is 0. So follow until this point here where they both meet each other. At that point, this will be the highest point for your resultant graph. Then after this point, you realize that Earth 1 approaches 0, so the resultant largely follow the one for Moon. So the final shape will look something like that. Understand? Okay. Then if I were to actually ask you to draw in the concept of potential, it will be the same graph because potential just asks you to draw for n. Clear? Okay. So now the last part, waves and superposition. Now for this topic, right, a lot of things that we need to remember. Mainly number one, concept of waves usually tests you a lot on phase differences as well as intensities. So for waves, just understand to calculate phase difference, I can use two things, the time difference or the interval difference, the displacement difference. So using the displacement over the wavelength times 2 pi will give me the phase difference, or the time interval with respect to the period will also give me the phase difference. However, the important thing is this. If I have two wave sources, how do I know whether they are in phase or out of phase? You can look at their angle. So if they are 0 degree phase difference, that means they are in phase. If the phase difference is not 0, they are out of phase. But if their phase difference is 180 exactly of pi, that means they are anti-phase. That means one is going up, the other one is going down. Okay? Next, any intensity of the wave can be calculated by taking the total power that is delivered or the energy delivered by the wave divided by the area. In this case here, intensity can be calculated by P over 4 pi r squared. Now this A here is area, so don't be mistaken, because intensity is also very related to the amplitude, which means the greater your amplitude, even greater your intensity, because it's directly proportional to square your amplitude. But it is inversely proportional to your radius, which means your area. So the bigger your area, the lower the intensity. But in waves, you learn the concept of Malus law, whereby it says that if I have a beam of polarized light, and I want to find the intensity of this polarized light, especially after it passes through different types of polarizer, I use the concept of intensity equals to I naught cosine square theta. Okay, now in this intensity concept wise, you will have to understand that for any plane polarized light, the maximum intensity happens at 0 or 180, whereas the minimum intensity happens at 90 degrees. So why is that so? Because if I were to draw a cosine square graph, it will look something like that. There is no 0 because it's a square graph. So the graph will look like that, like that. So you see, maximum intensity happens at 0, okay, whereas as well as 180 here. So this is 90. Okay, then this is 180. Whereas minimum intensity happens at 90 degrees. Okay, if you're looking at a polarizer one. Yeah. Okay. So what happens if, let's say now, because usually when we look at plane polarized light, it is either vertical or horizontal. So maximum happens at 0 or 180. If it's 90 degrees, then there is no intensity. But if, let's say, my polarizer causes my light to change at an angle with respect to the center, let's say 30 degrees, then how does this affect where my maximum or my minimum intensity is? I would have to shift all my axes by 30 degrees. So that means my maximum is no longer 0, it happens at like 30. My minimum is no longer 90, it happens at 120. And my next maximum will happen at 210. Okay. Understand? Okay, so if let's say your plane polarized light was initially already shifted by a certain degree, then just change the angle by adding or subtracting based on the Malus law. Okay, then under principle of superposition, you learn the concept whereby if two waves of the same type meet together, then their resultant displacement would be the vectorial sum of the individual displacement at that point. Okay, but make sure that the two wave meets have to be of the same type. But one thing I want to take note of is this. The intensity of your wave, right, always only dependent on the amplitude. There is a lot of misconception that is dependent on the instantaneous displacement. Meaning to say that when they use the concept of superposition and they say that, oh, the wave actually double in amplitude, the wave travel faster or travel more. As such, the intensity increases. No, it's because intensity is only dependent on the amplitude. So under superposition, it can range from 0 to maximum. That's all. There's no negative. Okay. Then in superposition, you also have one application, which is the concept of interference, whereby you have either constructive interference or destructive interference. So constructive interference happens when your waves meet at the same point, at the same time, and in phase. As such, the resultant displacement is usually larger than your individual displacement. So take note of this. Whenever you do constructive interference or destructive interference, always check first, is your two sources that comes out in phase or out of phase? Because if they are in phase, then the path difference for constructive is integer multiples of a wavelength. But if they are out of phase, for constructive interference, it has to be the integer half multiple of your wavelength. Understand? Then for destructive interference, if you realize that the two sources are in phase, then it will be the opposite. The integer half multiple of wavelength, but if they are both already initially out of phase, then it will be integer multiple of the wavelength. That's for interference. So usually for constructive interference, you have maximum intensity, maximum amplitude. But for destructive interference, it could be minimum intensity or minimum amplitude. Understand? Okay. Okay. Then the next type of question I'd like to test you as well is stationary wave, but in the concept of in springs. So spring-wise, there is a few ways they can do it. They can either close both ends or they can open both ends. But there is one new way that they like to test you on, they close one end, they open one end. So for stationary waves, understand that there is always two types of phenomena that you can see, the nodes and the antinodes. The nodes is the point whereby all the amplitude is zero. Antinodes is where the amplitude is the maximum. Okay, so at closed end, they will always form nodes. Open end, always antinodes. Understand? So for closed end wise, if let's say I have both sides that are closed, then the fundamental mode or the fundamental frequency, we call it F1, it will always be equal to the velocity divided by the wavelength, which is made up of 2 times of the length of the spring. Because always remember, the distance between one node and the other node will only give you half the wavelength. Okay, the full wavelength is given by one node to another node to the third node. So this is also half a wavelength. As such, your wavelength will be adjustable accordingly to your length of the spring. But what I'm trying to say here is that if it's closed at both ends, your frequency changes as such. Your fundamental frequency is F1, the second harmonic will be 2 times of the F1. The third harmonic will be 3 times of the F1. So it's just single multiple of your first fundamental mode or first harmonic. But if they are open at both ends, how will it change? The thing is, because both ends, both sides are nodes, you realize that the fundamental mode, which is your first harmonic, will, if let's say it's F1, then the second harmonic will be 2 times of the F1. And this is how second harmonic will look like. You will have 2 nodes. The third harmonic will be 3 times of the F1. You will have 3 nodes. Okay? So then the differing one comes in this one, when I close at one end, open at one end. So you have a node here and an antinode. You realize that the length of the string, which is from here to here, the entire length, is just 1/4 of your wavelength. It is not even a half a wavelength or full wavelength, it's 1/4. And that's how you get wavelength to be 4 times of the length. So as such, the fundamental mode, which is your first harmonic, will be F1. There won't be a second harmonic for a one end closed, one end open. There will only be a third harmonic and a fifth harmonic. Okay, so it will be the odd integers of each other, odd multiples of each other in this case, yeah, for stationary wave in the spring. So just take note of this. Next, the other concept or the application that they test you on is diffraction. Now in diffraction, the way to do the question is always very simple. First things first, recognize, is it single or double? And how do I know whether it's a single or double diffraction? Very straightforward. There's a single lead or is there a double lead? You see that? Because if you have a single lead, then this is just your normal monochromatic wavelength split to form fringes of bright and dark. And the reason for the different fringes of bright and dark, right, is just that the central one will be bright, and as the waves spread further and further, it becomes dimmer in terms of intensity, and hence the amplitude decreases. Understand? So the formula to use if it's a single slit diffraction is d sine theta equals to n lambda. But if it's a double slit concept, then this is where interference will happen, and the interference causes the bright and dark fringes that you can see. So in this case, the formula used would be x equals to lambda d over a. So what is all this formula talking about? D here will be a slit separation. This is a D. Sine theta is the order in which your light is actually the order of your fringes. So the central one will always be order 0. Then this will be the first order, second order, so on and so forth. Then symmetrical wise, first order, second order. Then n would be the order number and lambda would be the wavelength of the wave that is calculated by the distance between the wavefront. If it's a double slit experiment, then I can actually find the distance between the slit separation is equal to the wavelength times the distance that my slit is from the screen divided by my slit separation. So the distance between my fringe separation is equal to the distance of the wavelength times d here, and the distance between my slit separation. Okay. Then the third one is your Rayleigh criteria. Now Rayleigh criterion, right, actually talks about the resolving of your waves, especially if I have more than one slit. What happens is that I will have multiple interference happening. So when I have multiple interference happening, this will be the concept whereby do I find out if my waves actually resolved or whether they are unresolved. So what does a resolved wave mean? It means that, okay, we talk about Rayleigh criterion first. Rayleigh criterion in terms of wave, right, would happen whereby the maximum of one wave happen at the minimum of one wave. Can you see that? Whereas for resolved, it will be the maximum of one wave meeting the maximum of the other. And if it's unresolved, they don't meet, maximum don't meet the minimum at all. Okay, so Rayleigh criterion is where the maximum of one wave meets the minimum of another, and this is the type of diffraction pattern that we will see. So if I want to find the angle at which the Rayleigh criterion is fulfilled, I can just take the wavelength divided by the slit field. This will tell me what angle and whether or not my Rayleigh criterion is fulfilled. Okay. So for wave superposition concept, let's take a look at this type of question. So one type of question you like to test you is this part, where they give you two small coherent sound sources that are set up as shown. So since they are coherent means they are in the same phase. So therefore, constructive interference and lambda, destructive interference, and multiple of my wavelength plus half of my wavelength. Then they have a sound detector here, detecting sound from A to B. Okay, now you realize that in order for me to actually find whether or not it is constructive or destructive, I will always need to find this thing called the path difference first. Okay, so later we might have to find all of these. So first things first, they say sound wave frequency is 2.80 Hz, speed is 336. So to find the wavelength, all we got to do is just V equals to F lambda because it's a wave. And as such, lambda is equals to B over F. Okay, and my wavelength is given to be 12 centimeters. Okay, so now I have my wavelength, which is this. I can find out whether they are multiples of each other. Then they say the detector placed at N indicate a maximum intensity as it moves from N to P. So it's moving upward. The intensity varies between high and low. Why? Because there's constructive and destructive interference. Then they say at a certain position P, S1 here is given to be 372 cm. So this is the path traveled by the sound wave of source 1. Then S2 here is the distance traveled to be 402 cm. So determine whether at P here, is it constructive or destructive? So therefore, I need to find my path difference. The path difference is 402 minus 372, right? Then I check. Is it integer multiple of my wavelength or half multiple of my wavelength? So first things first, I will take 402 minus 372 will be equals to 30. So I will take 30 cm divided by 12 to find how many multiples is it, and it is 2.5. Now, since it's 2.5 and they are both in phase, that means this is a destructive interference, and hence low intensity of pulse. Understand? Okay. Then, but they say here, next one, the P, you will see low intensity. Next, the number of high intensity region between N and P. So how many high intensity and how many low intensities? So you realize that at P it is 2.5 wavelength. So understand this concept here. In the middle, the order is 0. If P is here and this is at 2.5, that means initially there must be a 0.5 and there must also be a 1.5. So these are my dark fringes. Can you see that? So dark, 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 destructive interference. The constructive interference happens in between them and there are multiple integers. So therefore, we will have a 1, n equals to 1 for constructive, and n equals to 2 for constructive. There's no 3 because the maximum at P is 2.5 wavelength. So as such, you will see 3 low intensity and 2 high intensities. Okay? Okay, so the next one, the intensity of the sound at N by S1 alone or by S2 alone is I. So they are trying to tell you that the intensity of both sound waves is I. Calculate at N in terms of I when both S1 and S2 are producing sound. So the intensity at N here, you realize is the maximum intensity, alright? So sound waves at N is due to amplitude. So what a lot of students like to do, right, is they like to add the amplitude, they like to add the intensity. They say, oh, at n is central maximum. So central maximum, right, then what I do is just for I plus I equals 2I. No, you cannot do that. Always remember intensity is directly proportional to amplitude. So if each of them I produces an amplitude of A and intensity is equals to amplitude squared, that means to say their total combined amplitude line is the vectorial sum of each other, 2A. As such, the total intensity will be equivalent to 2A squared, proportional to 2A squared. And as such, you get 4A. So if intensity is produced by A, 4A will produce 4 times your intensity. So the intensity is actually times 4. Understand? Okay, clear? So any questions so far? So this was a very quick revision of your promo, all the topics that I think you guys most likely will be tested for promo. So before the session, I want you guys to actually just scan this QR code and join the Kahoot to for a chance for the giveaway. So just scan it, log in, key in the game pin. Wait, let me give you guys the game pin first. Okay, so you guys can see the screen. I'm loading the game pin now. Just key in the pin on top. So I'll start the game soon. So those who haven't joined it can join. Okay, so I'll be starting the game. For projectile motion, what do we resolve a velocity vector into? That was fast. Yes, not bad, not bad. Yes, you only resolve velocity vector or actually any vector into horizontal and vertical components, okay? No upward, downward, no front, back, no left or right. Okay, good. The next one. Oh, what is Newton's second law of motion? Yes. Resultant force is directly proportional to the rate of change of momentum. So I already repeated, when they ask you to quote Newton's second law of motion, you do not say that it is equals to ma because that is what you've done in secondary school, and that's only assuming if your mass is constant. But for Newton's law, it is always directly proportional to the rate of change of momentum. Okay? Okay. Oh, Javier is still raining the visa, not bad. Next one. What is conserved in an elastic collision? Yes. So this is a trick question. what is conserved? Both kinetic energy and momentum is conserved, not just kinetic energy and not just momentum. Understand? Okay. Oh. Okay, number 4. What is the relative speed of approach and separation formula? Oh, for the first one, I think there's a typo here, but the answer is actually the first one, the B and A in swap position. Okay. Okay, the next one. Right. What is the period of orbit for geostationary satellite? What are not where? Yes, the period of orbit for geostationary is 1 day, not 365 days, because your satellite is rotating about Earth, not rotating about the sun. If it's rotating about the sun, then itself would be 365 days. Okay. Last question. Are you guys ready for the last question? When is the deadline for early bird sign up for group tuition? Yes, 16 October 2022. So that's now I remember I asked you guys to remember the date. Okay. So let's see who is the winner. Congrats, Rui Feng, you're in the third place. Joe is in the second place, and the first place is Elise. Okay, congrats, Elise. Now, for Elise, can you just PM me your address so we can send the notes to you? So PM me your address as well as we'll be sending to you the created notes, okay? Okay, so just type it in the chat, but don't forget to send it to me only, and not to everybody. Okay? Okay, good. So we end today's lesson. Is there any other question? If you have any other question, just uh message me in the chat. Otherwise, you guys can leave the chat, and good luck for your promotion preparation. Okay, anything you can also still chat in the Overmarks chat board in the website if you have any questions. Okay, bye bye. Yes, Zuli, you will get the recording of this session. It will be uploaded on YouTube, so you can go and watch it once we upload it. Bye bye. No problem. Bye bye. Gladys. Wait, hold on, Gladys. I'll share with you. Okay, so why is it that the frictional force is towards the left, right? Is because in order for you to bend your bicycle towards the left, your wheels need to move this direction. Can you see that? So in order for your wheels to bend, your whole body to bend towards the left, your wheel will be pushing towards the right. So that's why the frictional force is in the opposite direction towards the left. Understand? Now the rest, any question? No question? No problem. Thank you, Elizabeth. Good luck for your promos. No question, you guys can leave the chat already. And good luck for promotion. Hope you guys all promote.